Ladies and gentlemen, welcome back to the workshop. It's fantastic to have you here. Merry Christmas. I hope you're really enjoying the time off, the time with family. Hope you're having an absolute blast. Hope you're really enjoying your Christmas. Now, as we interrupt your Christmas celebrations, we're going to talk about things that hit, things that squeeze, things that are hit upon. Ladies and gents, we're going to be talking about presses, power hammers, anvils, and hammers. Thank you for joining me. So, first things first, over here, up on the right, this is a hydraulic press. Now, as much as I know about this, this is a Norton hydraulic press. I don't know anything else. That is all there is in terms of indication as to what this machine is. No stampings on the nameplate, no text anymore, it's all been rubbed off, so I have no idea exactly how many tons of pressure it exerts, but the eBay ad that I bought it from said it exerts 25 tons of pressure. Does it? I don't know. What I do know is this particular hydraulic press has the ability to move extremely far. Now, a fast-moving hydraulic press is lovely for forging steel because steel likes moving fast, and it's very much easier to move the steel when it moves fast. I used to use this when I was punching and drifting holes on hammers, when I was making hammers in production runs, which of course you've seen if you saw my series of videos titled Making 70 Hammers, and I'd have a punch in the top die, boom. Easy way to punch the hole. You know, you imagine that's the thickness of a hammer. Easy, fast, likes moving through the metal. You'll sometimes also see me welding up big billets of Damascus steel with it, because with that speed and that pressure, it's able to really move the material very fast. Lots of people are concerned about tonnage of a forging press. I'm a little more concerned about speed. I'd rather have a 20 or a 25 ton press that moves as fast as this and is a single stage pump as opposed to a dual stage pump where it's going to slow down than high tonnage, slow speed. You can do a lot with that fast speed. It can get uncontrollable, so you want to be careful with it so you're not going too far with your forging. But there is a point where that speed is just right, and it means you can have a lower tonnage press like this, supposedly 25 tons. Is it? I don't know. Might be less even, which would just prove it even better. But anyway, in terms of usage of this press, you can see the table here has T-slots in it. I've attached a 2-inch steel plate to which I can bolt anything else on. I've also got a hole that goes right through the table. Here, simply 4 bolts that fasten the plate to that die. When I take off this plate, you see in here, this turns. That means that by turning this down and bringing this further down the ram, I can control exactly where the ram stops, because it runs into that, boom, done. It's not going to go any further. Really handy feature. The press also has a speed control down here at the bottom that I very seldom use. I usually just go full speed and use this right here as my treadle by hand or by foot. So the press is extremely useful. It's a lovely bit of kit to have. I got a fantastic deal on this, and oh, yeah, no, I'm going to make some people jealous here. I bought this for £750, including tax and including shipping, £1,200 for this unbelievable piece of machinery. It's astonishing. I've been very lucky to find some great deals, and here's another case in point. Got a fantastic deal on this. This, of course, is the power hammer you see me using most of the time. This is a 100 weight Pilkington power hammer. Again, I got this on eBay, and it's one of those things, is these things are in such high demand that, like, when you find one, you want to kind of act fast. I did, got a fabulous deal on that, something like, $22.50. Like, that's an incredible deal for this piece of equipment. Of course, you've seen me do a dedicated video on this, but just to run you through again, what happens is the motor drives these belts, which drives this pulley, which drives the flywheel, which pushes this crank, which is connected to a piston here in a cylinder, pushing and pulling air back to this front cylinder housing, the ram housing, lifting and pushing down the ram. In here is sort of mechanism of valves that means that in this setting here, it forges. In this setting here, it's at idle, and so the ram will just sit down. And then in this setting here, it engages a check valve, and you actually pressurize the top cylinder, and it allows you to have a sort of clamp. It doesn't clamp with a lot of force, though. It's only really useful for any kind of light straightening or readjusting of the tongs. Mostly just run it as normal. More hitty things. This is a Sehenla power hammer. It's a much more modern design. And you really see me using this because I really don't like the control of it. It's a little bit haphazard. Even this thing that's old and sloppy, and I need to go over it and fix a lot of things, and it's got knocking and it's bad. It's in pretty bad shape. This, however, has even worse control. I can't touch stock as small as I can with this, and I can't touch stock as large as I can with the Pilkington power hammer. It doesn't hit as hard. Not a major fan of it. However, I do have it set up with these wonderful quick change dies. Very simply, each die that I put in has two 16mm round pegs. It slips in, it tightens from the side, and it's a very simple system because I can make it with very limited equipment. I can make up new dies without having to go to the lengths of cutting dovetails on a mill to the perfect angle, to the perfect fit, to be able to drive them in with a key. Very, very handy, especially in a shop without a mill or a shop with a mill but without knowing how to use a mill. That's me. You, of course, have noticed this power hammer hits at a much faster beat. It's a much faster beat than the Pilkington. That's the kind of speed that most power hammers nowadays in this weight class will hit, and it's obviously a great speed for drawing out and what have you. I'm quite a fan of the Pilkington speed, though. That's about 160 beats a minute, I believe, and I'm a big, big fan of that. When it comes to other hitting and beating objects, of course, we have this anvil here. This is a 51-kilo Brooks London pattern anvil. It is cast steel. It's the main anvil I use. I like it because it's got a nice narrow face. I can do everything I want in it without too much issue. It's also very sturdily mounted on a steel base, which is bolted into the ground with chemical anchors. Big fan of this anvil. Well, actually, I'm not really that much of a big fan of this anvil because all here, this is all MIG weld because the original cast steel chipped and cracked, and I've had to replace it with MIG weld so that I actually have an edge, which means I now have a soft edge because I never got around to hard facing it, which I'll probably do at some point. But for now, that means that I have a soft far edge and a soft edge here. Also had to cut away the step there. As far as I understand, these anvils are prone to crack. I certainly know mine did. I've got another identical one over here, which is again in very good condition, so I can easily kind of swap that in if I ever really wanted to, but I never really got around to it. Lots of people are often curious about what is the correct height to mount an anvil. And again, this is something that you're going to have to determine based on the work it is that you do. Rate your anvil height to the work that you do to give you an indication of good general work height for an anvil. Firstly, you want to be able to put a piece of steel between your legs so that you can hold it while you're chiseling. So of course, if you have a piece of steel between your legs and your anvil is too high, as I'm simulating by bending my knees, you're going to get a nasty surprise when that piece of steel kicks up and hits you. And then, of course, if your anvil is too low, you can't really get a good grip on it. I mean, you can, but you're going to end up having to work a lot more hunched over, bend your knees a lot more than you would otherwise. And so it's a compromise between low enough that you can get it between your legs, low enough that you can get a pretty good extension of the hammer as you swing, but not low enough that you're having to really force yourself to get down there. Find what works comfortably for you. If you're doing smaller work, you can work with a higher anvil. If you're doing heavier work and you're working with a sledge, that is where this comes in. That bad boy is a striking anvil. I first saw a striking anvil from Brian Brazil when I learned how to make tools with him, and it's a fantastic thing. It looks ugly, it looks ridiculous, and it defies the laws of what is meant to make a good anvil because it is soft. But there is a reason for it, and that is when you're working with a new striker, you don't want to go having them miss hit and hit a hard anvil and send chips flying and what have you, and femoral arteries and things like that. That's not often a great thing. But what it does do is it provides a good learning platform for learning tools with new people. I used to do a lot of classes, lots of new strikers, and therefore as a result of that, there are dents all over this, and thankfully nobody has been hurt as a result of this flying off. The other great thing about it, as you can see, is it is low down. This is 24 inches tall, which means that the striker, the man that's swinging the sledge, is able to get a full throw of the sledge, not only when they're hitting a piece of steel, but also when they've got a lot of tools stacked up. There are often times when making tools where the director will be placing an object, placing a tool this high up to be hit, and were it not for that anvil being so low, you'd be up here in your shoulders trying to hit it, trying to develop the energy needed to strike hard in that range of motion, as opposed to this whole range of motion where still, you're hitting it in your belly button, you're getting a much bigger throw. You can accelerate that sledge, or pardon me, let gravity accelerate the sledge instead of you having to work to accelerate the sledge. If we can let gravity do a job, it's often nice to let it do a job, because otherwise it gets tiring trying to fight gravity. Let's not try and fight gravity. There's no point doing that. Now, speaking of sledges, of course, there are a couple different sledges that I'll use. Most of them really have one very flat face and one slightly more rounded face. I almost always prefer using a slightly more rounded face to strike tooling, because you get a little bit more of a forgiving blow in terms of the angle that you hit. If I can demonstrate, flat side of the hammer, drop it on the anvil, it often will want to bounce off in a weird direction, as opposed to when you use the round side, it wants to come straight back up. You can imagine, you try and drop, if this is a flat surface, you try and drop a flat surface on a flat surface. If it doesn't hit at the perfect angle, it's going to want to cant down, flip and twist and all that fun stuff. So I like using the slightly more radiused side when I'm striking tooling. Same thing applies to a hand hammer. This, of course, is the square circle rounding hammer. Sorry, not planning on making any soon. I appreciate that lots of you want these things. We're making YouTube videos, and I apologize. I know, I'm so pleased that lots of you do have my hammers. I'm very sad that I'm not making them anymore, but we're making YouTube videos. It is a lovely hammer. One flat face, one round face, inspired by the Brown Brazil rounding hammers that I learned to make from him. And again, when I'm striking tools with that, I'll often use the round side of the hammer. When I'm planishing work, when I'm not trying to be very aggressive, I'll then switch to the flat side of the hammer. Back to sledges. Sorry to go back and forth. Couple different weights of sledge that I'll use. This one here is about 8 pounds. This one here is a lovely Brent Bailey sledge that Brown Brazil gave me. This is about 12 pounds. They're the weights that I like for using a sledge if I'm doing very small work. Very small. Like if I'm working inch stock or something, I can take the 8-pound sledge and just be fine and dandy. If I want to be hitting larger stuff, I then might end up taking a larger sledge too, just to help get the work done. Let gravity do some work for me. Now, of course, there's plenty of opportunity where you might want to use a cross-peen hammer. This is a cross-peen hammer. Now, cross-peen hammers come in many different styles and what have you, but in this particular one, obviously, just like any cross-peen, aside from the things that are happening in the middle, we have a peen and we have a face. Cross-peen, because the peen goes crossways to the handle. So the reason that we use a cross-peen is much like a baker will use a bread roller. You put that bread roller in there, you're able to do an extreme lateral draw of the steel, bread if you're a baker, and you're able to push the steel from side to side. That's when I'll be using a cross-peen hammer. So for example, doing an excessive draw on a leaf, or maybe an excessive draw on a spatula, switch to a cross-peen to get a really far-reaching lateral draw. Very handy tool to have. You can go on and on about hammers and, what is the best hammer and what have you. I personally, first things first, want to make sure that I have a nice radius on the faces of my hammer. So that means that on the flat face, it's only flat for about half the width of it, and the rest gently radiuses off. That way we really make sure that we prevent as many hammer marks in our work, but we can still get our work as flat as we want it. And I am quite partial to the rounding hammer, where we then have a squashed ball, so to speak, where it's very lightly radiused at the top, and then becomes far more aggressively radiused on the sides. Now, to talk about this. Now, this is a beast. This thing weighs like 670 pounds. It is a double horn, I believe, Peter Wright Anvil. She's a monster. It is absolutely enormous. Again, I'm so grateful. I got a fantastic deal on this. Got this from a wonderful local blacksmith who was shutting up shop. And it's a beauty. It's a beauty. Probably made late 19th century or early 20th century. And it was in a train yard, I believe, before the gentleman that I bought it from got it out of the train yard and used it himself for the entirety of his blacksmithing career. A lovely bit of kit. Myself, not a major fan of these large anvils. I like being able to get in closer to my work, and I feel a little inhibited by having this horn so far out this way and a face so wide. I much prefer that little bit of a narrow anvil, a little bit of a smaller working space to work with. This one's mounted a little higher. That's why you saw Joey using this, because he's a tall Dutchman and I'm not. I'm a short Englishman. But it's handy to have a different height anvil, just so that when other people are working, they can do it. I prefer using that other one. Swage blocks. Swage blocks. The thing that I say that I never use, but then still somehow often find time to use it. That is right, the swage block. Now, what is a swage block? You have all sorts of different holes for driving drifts through, and you have different forms here on the side, which are called swages. So you've got loads of swages, different swages. The the stand that holds a swage block. Here, this is a cast iron one, and it's great in many respects because you can position the swage block in many ways, but it's terrible in many other respects because it's mounted extraordinarily low, sometimes great, sometimes not, and there's no way to secure the thing when you're hammering on it, which is kind of ridiculous. So anytime I ever do like massive work on a swage block, maybe I'm upsetting the face of a flatter, which I've been known to do. Here's an upset flatter, and this often gets done in a swage block by forging a set down and then upsetting the face or putting a piece of square barring with a backing plate on the bottom of the swage block. And that'll require working with a striker, working in tandem or working in a team of 3 or 4 strikers to upset the face of it. This thing would go bouncing out over the place and it'd end up jumping off and landing on somebody's toes. So whenever I do extremely heavy work on a swage block with a stand like this, I'll take a ratchet strap and wrap it over the thing just so it's a little safer and more secure, not bouncing everywhere, making your life a misery. So yep, I say I never use it. Now I did say hitting things, but I also said squeezing things. This is my post vise. This is an 8-inch wide jaw. Post vices are generally leg vices either which way. I'm measured in the width of the jaw. This is an 8-inch wide jaw on this. It is a behemoth. It is enormous. Got it from a friend of mine in France. He had built this stand for it, which is lovely in the respect that this vise is mounted low down. I love having a lower down vise for forge work. It means I can swing hammers at it. I can be much more aggressive with my hammer blows, and it's a pretty decent height for, in fact, grinding, and that's why I do a lot of my big grinding work on a low vise in the grinding room also. So this is a French vise, and as you can see, the way it works is we've got a pivot here and a spring here that means that as we unwind it, the vise comes out and we're able to have an extremely strong and sturdy platform for hammering against. We do not get as rigid of a platform on an engineer's vise. These are cast steel, a lot more susceptible, or cast iron even, a lot more susceptible to breaking. And so for heavy forge work, that's where the leg vise comes into its own. They come in many different sizes, all the way from 3-inch all the way up to, bloody 10-inch leg vises. This is considered a big one. 4-inch leg vise is great for a lot of work. And on that note, ladies and gentlemen, I want to wish you a Merry Christmas. I hope you're enjoying your Christmas tree. It has been a total pleasure having you here in the workshop. Enjoy your Christmas, enjoy your time off, enjoy the time with your family. I'm looking forward to seeing you very, very soon. The videos will be sparse for a few days, but we're going to be right back at it, doing some more fun forging and casting and great things. So make sure you subscribe if you're new. Enjoy your Christmas, and I'm going to see you very soon.